The Game Boy console may have been one of the most beautiful pieces of electronics that humans have ever built. Despite only running at 4 MHz, no GPU, and with less RAM than a digital kitchen scale, this little gray brick conquered the world, and for many of us, our hearts. This is the original Game Boy. Launched on April 21st, 1989, the engineers at Nintendo had to make do with a hardware that was much more constrained than what we have today. Inside, it's powered by the Sharp LR35902 processor. It's not a Z80, one of the most popular microprocessors at the time. It's not a 6502 either. It's some kind of love child between the two, where the designers used budget constraints and a deep loathing for power consumption to maximize its capabilities. It's an 8-bit CPU with a custom instruction set and a modified memory map. You might think this design came out of desperation, but you'd be wrong. It came out of constraints. Nintendo didn't build the Game Boy to be impressive. They built it to be just good enough. Just enough to play games, just enough to be fun, and just enough to last long enough that your parents wouldn't yell at you for wasting batteries. This wasn't cutting-edge computing. This was the pinnacle of embedded engineering. Every transistor had a purpose. The Game Boy runs on 4 AA batteries and famously lasts up to 30 hours. That alone should win it a Nobel Peace Prize. Compare that to the Sega Game Gear or the Atari Lynx, both with better specs, but both died within 3 hours. You could actually finish a game on the Game Boy before needing to sneak out of your room to grab replacement batteries before your parents noticed. And a big reason for this efficiency is the CPU. The LR35902 was custom built to be small, cheap, and conserve power. It could clock down when idle, it disabled unused subsystems, it had no unnecessary logic. And unlike most CPUs today, it didn't dream of being a general-purpose computer. It dreamed of moving pixels and pushing sound through a 4-channel PSG. Let's talk about RAM. The Game Boy has 8 kilobits of working RAM. That's less than the size of a modern JPEG thumbnail. So how do you build Pokemon with that? How do you store hundreds of creatures, dozens of items, battle systems, text, animations, and maps all in that tiny footprint? You don't. You fake it. If you thought your data structures and algorithms course was difficult, the Nintendo developers make that look like a walk in the park. They reused memory for different systems depending on the context. They weren't just managing variables. They were managing when variables could exist. For example, the overworld map data and the battle screen shared RAM space. Because you're never in both places at once, this saves precious memory. The background graphics, those weren't freeform pixel art. They were 8x8 pixel tiles arranged in a tile map. Think of it like Lego bricks. You only have so many, but if you arrange them right, you can build castles. This let Nintendo store only the unique tiles and then reference them by ID, massively reducing the amount of data needed for visuals. The sound, only 4 channels, 2 square wave generators, 1 waveform channel, and a noise generator. No MP3s, no fancy PCM buffers, and yet those limitations define the Game Boy's iconic sound. Writing code for the Game Boy is like showing up to a gunfight with no weapon. Of the 256 opcodes, there's no native multiplication or division, and registers are basically glorified post-it notes. You want to multiply 2 numbers? Well, you better love binary shifts, loops, and table lookups, because that's your life now. You want a game loop? Cool. Now remember, you can't just draw to the screen. You have to wait for the screen to finish scanning that line, then sneak your data in during the vertical blanking period. They would literally count CPU cycles, unroll loops by hand, and optimize hop paths like their cartridges depended on it. Because they did. Some games use self-modifying code to change program logic at runtime just to save a few bytes of memory or a few cycles of execution. Want to create a parallax effect in a 2D environment? Sorry, no hardware support, but you can scroll different parts of the background at different speeds by dynamically updating tile maps mid-frame. Sounds complicated yet? Don't get me started on bank switching. See, the original Game Boy cartridges were limited to 32 kilobytes of ROM. That's not much, so they invented memory bank controllers, hardware mappers that let developers map in banks of ROM dynamically. You want more code, more levels? You're gonna have to page it in and out manually, mid-execution. Just hope you don't overwrite the function you're standing in. Developers wanted to push the limits. They started writing entire games in hand-optimized assembly because they could squeeze 10% more performance from it. And when every frame counts, 10% means the difference between lag and playability. Let's talk about Tetris. It shipped with the Game Boy and became one of the best-selling games of all time. The entire game is under 32 kilobytes, fits entirely in ROM, and runs on the most minimal parts of the hardware. No bells, no whistles, just clean, elegant engineering. Then there's Pokemon, a role-playing game with complex logic, hundreds of creatures, multiple save slots, and a full battle system, somehow running on the same CPU. You know what Game Freaks did to make it fit? They wrote their custom text compression system. They reused enemy encounter logic for menu animations, and they stored Pokemon stats as packed bit fields, cramming data into every possible crevice. The LR35902 microcontroller looked like the bottom rookie, but Nintendo engineers crafted it into a superstar. It's a beautiful example of embedded software engineering, hardware design, and relentless ingenuity. You could time your logic to the exact cycle. You knew how long each instruction took. You knew when interrupts would fire. That kind of precision is gold when you're doing things like synchronizing audio with graphics without any operating system to help you. The modern approach to embedded systems often starts with a microcontroller that's overkill, a few hundred kilobytes of unused RAM, and a debug console bigger than the application. But the Game Boy, it didn't have the luxury of all that bloat. It had constraints. and constraints when used right became the source of creativity. So yes, the Game Boy wasn't the fastest, the prettiest, or the most powerful, but it was enough. In embedded design, enough is everything. Enough to boot, enough to render, enough to last long enough for your batteries to die and your childhood to begin. Today we live in a world where devices are disposable and software is bloated, but back then they made magic with kilobytes. And they did that on a chip that most engineers today wouldn't give a second glance. The Sharp LR35902 wasn't just a CPU, it was a philosophy. Nintendo engineers crafted their hardware and software to push the boundaries of what was thought possible. As Sun Tzu says, in the midst of chaos, there is also opportunity.